It's summertime again, and we are going to have our summer holidays. Due to the high temperature nowadays, most of the people have air conditioner, which is commonly known as AC. So today we will see how AC works and its inner mechanism. You're watching Beyond, and let's get into our video. The air conditioners we use are generally made up of two connected coils known as evaporator, which is inside the room, and the condenser, which is kept outside. There is a continuous flow of refrigerant fluid within these two. The main function of the evaporator is to maintain the temperature colder than that of rooms, while the condenser maintains the temperature hotter than the surroundings. When the AC follows these two functions, then the continuous flowing fluid will absorb the heat in the room with the help of evaporator and comes out through the condenser. This is the principle that is used by the AC. To achieve this principle practically, we need two more components, a compressor and an expansion valve in between the evaporator and the condenser. Now the main work of the compressor is to increase the pressure of the refrigerant. The compressor handles the refrigerant in its gaseous state so that when it compresses the gas, the temperature rises along with the pressure. The temperature at the compressor outlet will be far higher than the atmospheric temperature. This hot gas from the compressor comes out through the condenser. For the condenser to push out all the heat isn't that easy. So we will use a fan at the condenser to push out the hot air. Further, during heat ejection, the gas gets condensed into a liquid. An expansion valve is fitted at the exit of the condenser, which helps to restrict the refrigerant flow, which in turn reduces the pressure of the fluid. We may know that it is possible to boil a liquid just by reducing the pressure around it. This happens inside the expansion valve. When the pressure drops, one part of the refrigerant liquid gets evaporated. For this to happen, energy is given from within the refrigerant, due to which the temperature drops. This helps to produce cold refrigerant inside the AC. This low temperature refrigerant should be at a temperature lower than the room's temperature. Now when it is passed to the evaporator, the temperature of the room drops. The refrigerant gets converted into vapor during this heat absorption at the evaporator. This is how our AC works. So is the video over? Not yet. Now we will see what ton means in our AC. The ton means how much heat can be absorbed by the evaporator in our room, which in other words can be said as the heat removal capability. In an actual AC, the compressor is near to the condenser and the expansion valve sits near the evaporator. When this is done practically, there is a drawback. Near to the evaporator coils, the air temperature will be quite low. This will lead to the water condensation on the evaporator coils. So to remove the water, we will use a pipe which is most commonly kept outside. To maintain a constant temperature irrespective of the load, the modern ACs use a variable speed motor technology called inverter technology. Just by adjusting the motor speed, the condenser speed, the refrigerant flow rate, and the cooling capacity can be controlled accurately. The compressor of an AC is designed to handle only vapor. Even a small fraction of liquid can damage the compressor. To overcome this, evaporator is designed in such a way that the liquid is converted into vapor and the vapor temperature is increased by 5 degrees to 8 degrees Celsius more for safety purposes. Then to make sure that only vapor enters, there is a special kind of valve called thermostatic expansion valve, which in short is known as TXV. The TXV is almost the same as the expansion valve, but in this the temperature of the bulb controls the needle. The bulb is connected to the evaporator exit. The refrigerant inside the bulb is separated from the main refrigeration cycle by a diaphragm. If the bulb is hot, the refrigerant inside will be evaporated and the needle moves down. The sudden cooling is obtained by the restriction of the expansion valve. The narrower the restriction, the cooler the outlet refrigerant will be. TXV helps to maintain the vapor at the compressor and avoid damage. However, TXV does not control the temperature, it only takes care that compressor receives only the vapor state. Hope you understood the working of an AC. Thank you for watching this video. If you like this video, hit that like button. Don't forget to subscribe to my channel and hit that bell icon to get instant notification whenever I release a new video. Do share it with your friends and comment on what we need to speak next. Always remember to think big.